Last time we talked about what are radicals. Okay, today we are going to talk about section 9.2, how to simplify them. So for radicals, we said we are going to talk about simplifying, add, subtract, multiply, and divide, right? So to simplify radicals, we want to have few conditions, okay? Simplified. What kind of things we call it simplified? So we say we don't want to have a negative inside the radicals. Okay? And we don't want to have roots inside the radicals. Then we talk about them. What do we mean by that? Okay? Also, we don't want to tangle fractions with radicals fractions. So, we don't want fractions inside the radical either. Okay, then we don't want to have radicals and in the denominator. Okay, so let's see what do we mean by that. And for no negative inside the radical, if it's odd roots. Okay, so for this one, we can just take the negative outside for our roots, right? So we say if it's a cube root of negative 27, we know it's a negative 3, right? Because negative 3 times 3 times is a negative 7. Then we can do it this way because you can look at the negative 3 3 times. So that's why you have this, right? Another way to look at it is because it's odd radicals, then we can have a negative inside, right? So if you take out negative, then become negative 27, cube root of 27. Then this one is 3. Then you attach number to it, you still end up with negative 3, right? So if it's odd roots, you can just take negative outside, okay? So then if it's even root, so if it's even roots, okay, and if inside is the inside it's negative, then we say not a real number. Okay, for now we just do that. Okay, or you say it doesn't exist. We just do that way. Okay, then another one is using a imaginary number. Okay, using I, but not for this class. Okay, so if it's a root, then you can just take the negative outside to simplify. So we don't want to have a negative inside the radical. Okay? And we don't want to have roots inside the radical. Then let's talk about that. Then you know fractions and radicals, we don't want to mingle them together. Okay? So no fractions inside the radicals. Also, no radicals in the denominators. We always keep denominator simple, and for LCD, for fractions to add subtract, right? Okay, so and we want to simplify them according to those rules to make things. That means what? To make, also it means to, that is to make the inside of radicals as simple as possible. That's the whole idea. Okay, you want accuracy, so we use radicals for the accuracy instead of using decimals. But we want to make the inside of the radicals as simple as possible. Okay, so that's the idea. Then let's see how we are going to do that. So before we do that, we wanted to talk about a few things first. Okay, we wanted to talk about product rule of radicals. It's hard to see the green, right? Okay, so we want to see the product rule of radicals first. Okay, how to operate the radicals. So it has such a characteristic. Okay, if I have an nth root, right, for A and nth root of B, if they are same roots, okay, then we can put them together, or we can split them. That's when you multiply two radicals if they have same index. Okay, then you can either split them apart or put them together. Okay, of course, all those things are real numbers. If they are not real numbers, we do things differently. Okay, so we are talking about in the real world, we are doing this way. You can take a look. If it's square root of 4 times square root of 9. So square root of 4 is what? 2. Square root of 9 is what? 3. When you put the two radicals together, nothing in between, it means what? Multiplication. Okay, two symbols together means multiplication. So then that would be 6, right? If you multiply inside 4 times 9, that would be 36. Square root of 36 is that same thing as a 6, right? Are they the same? Right? So that's what we are talking about. We can split them or we can put them together. Okay? It has such characteristic. We call them what? Product rule. All right. So we are going to use this product rule to simplify radicals, to make what? To make inside of the radical as simple as possible. Okay, so minimize the radicand. Radicand means inside. To make that as small as possible. Okay, so if we have square root of 45, big number inside, then we want to make inside as simple as possible. You can do that. Okay, one way is square root, 45 is square root 9 and square root 5. Then square root of 9 is a good number. That means what? 3 and square root of 5, right? It means what? Multiplication. Okay, these two numbers are the same if you put it into the calculator. Would be what? 7 times 7 is 49, 6 point something. Okay, it's a decimal. And this one is 2.718 something times 3 becomes 6 point something. Okay, so let's see. Another way to do it is we do the trees. Okay, so you do 45 will be what? 9 times 5, this is 3 times 3, right? So it's a 335. So we rewrite this what? 45 becomes 335, right? 3 times 3, 9 times 5, 45. Then we say square root means what? To find the root of square, right? So a square, a twin, then the root itself will be what? This one will be 3. That's your 3, right? When you take out the root outside, then when you have a root inside, square root, then 3 is the root, then the square is inside. Then you want to take out. Then remaining one will be in the 5 will stay in. Okay, so you can do it, they end up same. So you can do it this way. Okay, or you can use product rule to split it if you can see a good number right away. Okay, so if it's a cube, negative 56. So we have a negative inside of the radical. We don't want it. So we can, right? We can do it this way. Negative, take a negative out first. Okay, then 56 is what? Cube root of 8, 8 times 7, right? Both are cube roots. So, because cube root of 8 is a good number, which is 2, right? So that would be negative 2 cube root of 7. That's how we simplify. Okay? Then another way is we can do what? You can do it here, right? So you split that one, you can do it this way. Or, right, you can do it this way, negative cube root. Then you do the trees, then 2 times 2 times 2, 8 times 7, right? 56. Then cube roots we are talking about is find the root of cubes. So any cubes, you have to show the root. Then take outside, then that would be 3. Okay, so that would be negative 3 in cube root of 7. End up same. Okay, we prefer doing this way. Sometimes we don't see how things will be multiplied by 2 numbers. One number is a good one, just take a cube out, right? So we do the trees, then we compare. So we don't want to have roots inside the radicals. So then every 3 of them triplet, then you show the roots outside that way. Okay, so if you have this one, 48 and x fifth, y third, take a square root. Okay, square root means what? Every 2 of them, you have to show the root. So you do 48 is what? 4 times, okay, 6 times 8, right? So this one is 2 and 3, this one 2, 4, and 2, 2. So you end up those things, right? So you will write a what? Like this. 2, 2, 2, 2, and 3, right? You don't do the middle part, tree branches. You do the tree leaves, we call them, the bottom one. Then when you multiply, you get back 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 3, and back to 48, right? Then your x will be 5 of them, your y would be 3 of them, right? Then we say we are going to find the square roots. Then find the root of square. So when you find the root of square, you don't need that thing anymore, right? So for this one, that's the square. Then you find the root. That would be 2, right? Then every twin, then you take out, means multiplying. Then 3 stay inside, right? Then this x go outside. This every twin, then you go outside. Then y, you go outside, right? Then what's left? You keep them inside. You have one of the 3, right? You have x and y. Then you find that you write the answers in the simplified way. 2 times 2, 4. So you have 4x squared y outside and square root of 3xy inside. So that will be the simplest form. It means what? The inside of the radicals as simple as possible. Okay, that's how we wanted to simplify them. All right. Okay, then let's take a look at the next one. So next one we have cube root of 40 x6 y 4 z 5. So if you don't see it right away, you just spread it out like this. Okay, so cube root, right? 40 is what? 2 times 2 times 2, that's 8 times 5. So you do your trees, right? Then x6 means what? How many? 6 of them. y4 means what? 4 of them. z5, so when you start it, you can spread it out. Later on, you get used to it and you know it right away. Okay, so for cube root, we need to find out what? The root of cubes. Then you show it outside of these things, right? So inside still cube root, right? Then outside show the root, like a triplet, the root will be what? 2. Then you don't need the cube root anymore because you already show the root, right? For this, x and x, right? So you have what? X and x. Or you can write what? X squared, because it's 2 of them, okay? You just spread it out first so you can see it. So this one is y, one y, then triplet, another z, right? Then what's left? You don't have root and inside the, anymore, cube anymore, but they stay inside of the root, so supposed to be 5. Then you have y, you have what? 2 z's, so, right? So then you will write the final answer as what? 2x squared yz cube root of what? 5y z squared, right? That's how we simplify it to make the inside of the radicals as simple as possible. That's called simplifying. Okay, so we use the product rule to separate them like those, or we just follow the rules we need to follow. No negative inside, no roots inside, right? Another property we have is this. We'll call it quotient. Okay, quotient rule. Quotient rules are this way. Okay, then just one quotient rule. And if you have a situation like this, okay, it's saying if they are dividing, quotient is a division, right? Then you can put them together, if they are together, you can split them. Of course, b cannot be 0. Denominator cannot be 0, right? You can do either way. It has such property. So, if you look at some examples, if I have 64 divided by 4, right? Square root of 4. 64 is what? 8. Square root of 4 is 2. Then you divide them, end up with 4, right? What happens if you combine them? 64 divided by 4, that would be what? 16. Square root of 16 would be what? 4, right? Are they the same? They are the same. That means you can combine them, you can split them. And if they both are real number, okay, we are talking about in real world. So we use this to simplify the radicals as well, okay, for things we have fractions. Okay, let's look at next page, page 40. Then when we have this situation, okay, 7/81. So do we have a fraction inside the radical? We don't want that. We don't mingle the crazy things with fractions. Okay, so according to this, we can just split them, because you can see 81 is a good number for a square root. So if you split them, 9 and 7, right? So it's a fraction, but we don't tangle the radicals with fraction for the denominator. For the numerator, it's fine, okay, because it's a number. Okay, we just want to make the denominator simpler. Okay, so if you have 12/49, you can see that 49, oh yeah, we can split them, make a good number of it, right? Because square root of 49 is a good number, so you split them. So that would be 7 square root of 12. Then you need to double check, are you done or not? Because at the same time, we want the inside of the radicals as simple as possible. Then you need to check it whether or not 12 is the simplest one. Because 12 is what? 2 times 2 times 3, right? 4 times 3, yes. It's a square root, so you need to show the root of square. So you should write 2 square root of 3/7. So that would be the simplest way to show that radical. Right? And if we have this one, let's take a look. So if I have 5, okay, 5 times 4 root of 48 over 4 root of 3. Just happen you look at it, both are same roots, right? Then you find out 48 divided, if I put 48 and 3 together divided by, then you have 16. Then 4th root of 16. It's a good number. Okay, right now it's separated, so we put it together. Okay, so you would do 48/3. Don't forget your 4th root. Okay, then if you put it together, then that would be 16. That would be 5 times 4th root of 16. And this is a good number. Becomes what? 5 times 2. Then that's how we simplify. Okay? So, let's see. Next one, if you have 8 cube root of 54 m to the 7th power and cube root of 2m. Okay, then you decide whether or not you want to combine them. Sometimes we split them. Sometimes we combine them. This one looks good because 54 divided by 2 is 27. It's a good one for the cube rule. Same thing as m7 divided by m, right? So then we are going to combine them. So that's cube root. So 54 m7 to m. If you do that, you'll find out, oh, sounds good. That's 27. So that would be what? M6, right? Then you will have 8 times what? Cube root of 27 m to the 6, right? Then you can just split them, or you can just look at it. This is a 3 times 3 times 3, right? This is 6 of them. Then every triplet, then you can put them out. So that will be what? That one will be 3mm squared, right? Then, so you will write your answer as what? 24m squared. That would be the simplest form. All right. So remember this. What kind of things are required then to simplify your radicals, right? So you don't want a negative inside the radicals, no roots inside the radicals, no fractions inside the radicals, no radicals in the denominator. Then you make the inside the radicals as simple as possible. You need to remember that. Okay? So, and next one, we are going to do some powers. Okay? Powers. Okay, of radicals. That's C. All right. So, we are going to take a powers for the radicals. So, let's observe some examples. So, if I have a squared, take a cube root. Or, I have cube root 8, take a square. Let's see. So, this one, what do we have? We will be what? 64, take a cube root, that would be what? That would be 4, right? 4 times 3 times. Or you can do what? Cube root of 8 is 2, then you 2 square, that would be what? 4. Are they the same? Then, what's the difference? The difference is this one is what? Power first. Then you take a root, right? And second. Then this one is what? You take a root first. Then you take a what? Power second. Did they end up the same? They are the same. Okay? So, what do we say is, if you have a number, A, any number, right? Maybe 8, maybe 4, or maybe 7, right? You take some power, then you take an nth root. That means what? It's the same thing. You take the root first, then you take a power. That's what we are talking about. Okay? When you take a power of the radicals, power, this is a radical, right? You take a power for it, it's the same thing. You can take the power first, then you take a root. Okay? Then also we talk about, because we said radicals are opposite of exponents, right? Characteristics wise. So Then we keep reviewing what? The power as well. We say a, b, and power would be what? a to the nth power, b to the nth power. We call this what? Power of a product, right? You have two bases. Then you need to distribute your power. Then if power on power, that would be what? A m to the n, right? We call this power property. So power on power, you have to multiply your power. So when we have a bunch of radicals, we are going to take some powers. We are going to use all those properties. Okay, first one, we have those property, and you take a power first and rule second, or rule first and power second. Also, if inside is a radical and you have nth power, you need to distribute n power to everything inside, even they are radicals. Okay, so we are going to take powers for some radicals, power of radicals. We are going to take the power of radicals, then we need to simplify them. Okay, so for the fourth power, I have two things inside as a base. Okay, one is 3, one is square root of x fifth. So you need to distribute 4 to it. So we take a radicals with power. So you have 1 is 3 to the 4th power, x fifth, square root of the 4th power, right? Then you know 3 to the 4th power is what? 4 times 81. And for this one, you have radicals with power, but the x fifth takes square root, not a good, clean result, right? So what do? We can use this property. You can do the root first, then do the power, or you can do the power first. So what do? So we can just say, okay, x, you distribute inside, then 4 times 5 is what? 20. Because even number to take a square root is much easier, right? So we just times the, so then what is the square root of x 20th? So how many double, right? Twin inside for x 20th? 10 of them, right? It's 20 divided by 2. So you end up is what? 81 x to the 10th power. Okay, that's how we use those properties to do what? When you apply a power to some radicals. Okay, then we want to get the result as simple as possible. Okay, next one. Right, for the cube, some radicals for the cube. Then how many bases inside? 3 things, right? So you need to distribute each one of them. So it's a 2 to the 3rd power, y to the 3rd power, cube root of x to the 3rd power, right? And cube root of x, that's the simplest form. But when you take a cube, that will end up a what? Right? So 2 to the 3rd power is 8y cubed, right? Then what do? For the cube root of x, right, to the 3rd power, you can just move inside, right? If you move inside, you can see what's the cube root of x cubed? The root for the triplet is the x, right? So you will write your answer. 8xy cubed. Usually we follow ABC alphabetical order. All right, that's how we simplify a power of radicals. Okay, so another one is 5x cubed root of 4x to the square. Okay, that means you multiply them twice, that you distribute to 3 bases. So you have 5 to the square, x to the square, then cube root of 4x, you take a square, right? Okay, then 5 squared is 25, then x squared, then 4x take cube, nothing you can take out, right? When you apply the square, that means you move 2 square inside, like those. You move this m to the inside here, right? So it ends up what? 4, then square, 4 square is what? You have 4x take a square, right? So what do we have? 25x squared cube root of what? 16x squared, right? Then, are we done? You have to think about it. Because cube root, then if you have cube inside, you have to show the root outside instead of keep them inside, right? X squared, only 2 of them, it's not a triplet. You cannot show the root. But how about 16? 16 is what? 2, 2, 2, 2, right? Take a cube root, you do have a triplet. Then you have to show the root outside. So that will be 25x squared. Then these 2 should be outside of the cube root, right? Left over is 1 of the 2, right? Then x squared, right? Then you finish your thing by what? Because 2 and 25, they are multiplying. You need to put it together. Become x squared cube root of what? 2x squared. So that would be your answer. Okay? So this section, we talk about what? Simplifying radicals. So for radicals, it will take you no time for add, subtract, multiply, and divide. Relatively simpler. But your problem will be on the simplifying radicals. Okay? Somehow you will just mingle your thinking and you didn't simplify it enough. So you have to remember, simplifying for radicals means you have to satisfy 4 rules, right? Which 4 rules? No negative inside the radicals and no roots inside the radicals. Then same thing, no fractions inside the radicals. And another thing is what? No radicals in the denominators. You need to remember those. Okay? That would be the rules for simplifying radicals. That would be our section 9.2.